Time series forecasting has a massive usability problem. The mathematical models are highly capable, but actually getting them to run is locked behind a wall of technical prerequisites. To predict future trends using traditional methods, you can't just ask a question. You need a data science background, specific code libraries, and meticulously shaped input data before a model can even read the numbers. NEO autonomously built a platform called ChronoSight that takes that tangled knot of technical requirements and straightens it out. The interface works entirely through plain language. You type a question like, "Show me the Apple stock price forecast for the next 30 days," and the system immediately returns a visual forecast, complete with trend analysis and confidence bands. This democratizes data analysis. Instead of spending hours writing complex Python scripts to configure a model, you simply state your intent, and the platform handles the execution. The forecasting engine driving this platform is Google's TimesFM. It is a 200 million parameter foundation model specifically designed to process time series data. The defining feature of TimesFM is zero-shot forecasting. This means the model produces highly accurate predictions without ever being fine-tuned on your specific dataset. A standard machine learning pipeline requires a fine-tuning loop, gathering historical data, spending compute time, and managing parameters. Zero-shot inference bypasses that loop entirely. You point the model at a data source, specify a time frame, and it runs immediate inference. TimesFM can generalize across different industries without domain-specific training, because Google trained it on a massive, highly diverse corpus of real-world time series data. It has already learned the underlying patterns of how numbers move over time. By removing the need to train a custom model for every new dataset, this zero-shot approach is the exact mechanism that makes frictionless, on-demand forecasting mathematically viable. A foundation model still needs precise data inputs. To bridge that gap, ChronoSight uses an intelligent interface routing layer, eliminating the need to manually configure your data sources. When you submit a plain language query, the system parses the text to identify your intent and determines exactly which historical dataset it needs to fetch. The parsed prompt routes to two primary pipelines: live market data via Yahoo Finance and curated economic datasets via stats models. If a query doesn't match, it avoids a silent error. A structured fallback loop suggests available datasets and how to reformulate your question. This routing architecture is the vital bridge. It translates messy, unpredictable human intent into the rigid, precise data retrieval operations the foundation model requires to function. Under the hood, the backend is built on FastAPI and Python 3.10. FastAPI's asynchronous capabilities are crucial here, allowing the system to handle the heavy inference workload without blocking the input and output operations. The front-end interface is built with React 19 and TypeScript, bundled with Vite, and uses recharts to render the actual forecasting visualizations. Because the model is optimized, it runs entirely locally with incredibly low overhead. All you need is 2 GB of disk space to store the model weights, and a minimum of 4 GB of RAM. When the inference process is fully complete, the ChronoSight interface immediately generates a visual output built from 3 specific components. First, the historical series plots actual measured values up to the present. Second, a dotted line reveals the projected forecast. Finally, shaded confidence bands physically widen into a cone shape, correctly reflecting that predictions become less certain further into the future. Together, this 3-part visualization instantly communicates both the predicted outcome and the inherent statistical uncertainty of that prediction without requiring you to read raw numbers. ChronoSight surfaces a persistent educational disclaimer for a reason. These forecasts are for exploratory purposes and should never drive direct financial decisions. Zero-shot forecasting shines for quick baseline comparisons, exploring multiple time series, or when historical data is limited, but it falls short in production financial environments. High-stakes modeling requires rigorous validation against holdout periods and the deep integration of fundamental, domain-specific data. You can immediately access this end-to-end forecasting pipeline and start running your own queries by installing the NEO extension in VS Code or Cursor. Foundation models cannot replace dedicated financial modeling, but by removing the technical friction, they successfully give anyone the power to statistically explore the future in seconds.